Asynchronous federation uses message bus technology to manage information exchange between two independent systems. The integration of multiple independent systems can be mediated through message bus technology. Instead of direct interactions between two systems, the first system submits a request to a message bus. The request is queued in a message queue. The second system looks in the message queue for an appropriate request. The response is submitted back to the message queue or directly sent back to the first system. This approach simplifies interactions with systems such as indexing systems, Elasticsearch, Solr, Databook, or DataBridge, services such as the SEED Sustainable Environment Actionable Data Service, and workflows in CSA Cyber Integrator. Based on experiments within the DataNet Federation Consortium, we assert that interactions between independent systems can be done using any of these three mechanisms. Tightly coupled federation, which establishes a trust mechanism to enable common operations. Loosely coupled federation, which encapsulates knowledge needed for interaction and knowledge procedures, microservices, or storage drivers. Asynchronous federation, which eliminates the need for direct interaction between the two systems. Each system can implement separate knowledge procedures for interacting with the message bus. All of these approaches encapsulate the knowledge needed for interaction. The encapsulation is either done through middleware drivers or through microservices or through messages. The challenge with federation of two systems is the capture of the knowledge needed for interaction. An emerging technology is the use of virtual machine images. The application or service is encapsulated in a machine image. The machine image is moved to the site where the application or service will be performed. Data exchange is done between the machine image and the data grid, providing input data, files, and retrieving data products. This is a form of a loosely coupled federation. It has been employed by the iPlant Collaborative to support execution of genomics applications at high-performance computing facilities while the input and output files are retrieved from the data grid. The iPlant Collaborative uses the Docker machine image technology to encapsulate applications with their associated libraries and operating systems. Docker uses a Docker engine at each location to manage interactions with the local operating system. This minimizes the amount of software that has to be encapsulated in the Docker image. The Docker engine can run any Docker image and execute the encapsulated application. The iPlant Collaborative has implemented a portal for interacting with applications called the Discovery Environment. This manages the encapsulation of applications into Docker images and manages data exchange between the data grid and the Docker image. Applications can be registered into the Discovery Environment, which can then track their execution and provide status information back to the user. The Discovery Environment can act as a mediator between the data grid and an external service. The GABBS Geospatial Data Analysis Building Blocks project at Purdue University is a National Science Foundation project to develop interactive tools and models for processing, analyzing, and visualizing geospatial data. The project has developed a set of web services that can be used to manipulate geospatial data. The services are available at purr.purdue.edu projects geodibs/view. The services are deployed on a HUBzero platform. Their use requires that a data file be moved across the network to the service. The analysis is then applied, and then the result is moved back across the network to the submitter. For large data sets, it is more efficient to move the service to the data. GABBS has encapsulated their services in a Docker image. The Docker image can then be registered and executed through the Discovery environment. This provides a way to encapsulate the knowledge needed to apply a service, move a copy of the service to the data location, and apply the service at the storage system. Take 7 minutes and complete exercise 115. Which asynchronous federation mechanism is most useful to your research collaboration? Message bus and sending messages to a remote system? Discovery environment and use of Docker images to encapsulate a service? Please load a paragraph describing your conclusions into the Lifetime Library in the subcollection class INLS 624 by the end of today's class.